with number 11, f of x is equal to x squared plus 2x, we're interested in the derivative of f of the natural log of x. There's a couple of ways to go about this. The first thing that probably comes to mind is, well, let's write what f of the natural log of x is equal to, which means we're going to plug ln x into our function. So we're going to have ln x squared plus 2 times ln x. And now we're going to derive this. All right, so when we derive this, f prime of ln x, okay, what we're looking at is we have 2, because we have a chain rule here, we have an inner function being squared, so 2 comes out front, and then the natural log of x to the 1 less power. I don't have to write a 1 up here, but I'm gonna. All right, and then times the derivative of the inner function, and the derivative of the natural log of x is 1 over x. Plus, and then 2 natural log of x. 2 is a coefficient, so it will move right into our derivative. And the derivative of the natural log of x is 1 over x. So here's our answer. We just have to make it look like one of these answers. Well, 2 times natural log of x times 1 is 2 ln x. And that's over this x right here. Basically, we can move these two terms up into the numerator. We can move this 2 up into the numerator as well, so we have plus 2 over x. And we have a common denominator, so we can have twice the natural log of x plus 2 all over x, which is a. For 12, h is a function defined everywhere. H of 4 is equal to negative 3. The derivative of h is also defined everywhere. H prime of 4 is equal to 2. We have to do a couple of problems involving h. All right, the first one says, here's a new function, p of x. It's equal to e to the x times h of x. Find p prime of 4. Well, before we find p prime of 4, let's find p prime of x. This is e to the x times h of x, so we must use the product rule. Derive the first, e derives to itself, keep the second, h of x, plus keep the first, and derive the second. The derivative of h is h prime. Now we're interested in p prime of 4, so we'll just plug in 4 for all x's. E to the 4th, h of 4, plus e to the 4th, h prime of 4. H of 4 is negative 3, so we have negative 3 e to the 4th. H prime of 4 is 2, so we have 2 e to the 4th. And again, this answer is fine, but we could also combine our like terms here, and we have negative 3 plus 2 is negative 1, so negative e to the 4th. That's an answer. For part B, w of x is h of x cubed, find w prime of 4. This is a chain rule. We have an inner function being cubed. So let's get w prime of x first. Derive the outer function, so that's 3 squared up there, right? The 3 comes out front, and then we drop the exponent by 1. Keep the inner function, so h of x stays in the middle, and then multiply this by the derivative of the inner function. The derivative of h is h prime. We want w prime of 4, so that will be 3 times h of 4 squared, times h prime of 4. So we have the chain rule done. H of 4 we're given as negative 3, so we have 3 times negative 3 being squared, times h prime of 4, which we're given to be 2. Negative 3 squared is 9, times 3 is 27, times 2 is 54. All right. G of x is the inverse of h. Find g prime of 3. Well, g prime of negative 3. G prime of negative 3 will be 1 over h prime of g of 3. Negative 3, excuse me. There we go. All right, so we have to go back to the main stem of the question. We know that h of 4 is equal to negative 3, which means g of negative 3 is equal to 4. Right? We swap the x's and the y's. So g prime of negative 3 will be equal to 1 over h prime of 4. And we know that h prime of 4 is 2, so our final answer is 1/2. And finally, f of x is the natural log of x squared minus 5x plus 2 times h of x. Find f prime of 4. Well, f prime of x, we have the natural log of an inner function, so we're going to use the chain rule. The chain rule says that the original function, the original extension, x squared minus 5x plus 2h of x, will be our denominator of our derivative. The numerator is 1, and then we're going to multiply by the derivative of the inner function. But because the numerator is 1, we can actually just put the derivative of our inner function right into the numerator. So x squared derives to 2x, 5x derives to 5, and 2h of x derives to 2h prime of x. We're interested in f prime of 4, so f prime of 4 will be equal to 2 times 4 minus 5 plus twice h prime of 4 all over 4 squared minus 5 times 4 plus twice h of 4. So we have 8 minus 5, and then we have twice h prime of 4. h prime of 4 is 2, so we have twice 2, or 4. In the denominator, we have 16 minus 20 plus twice h of 4. h of 4 is negative 3, so 2 times negative 3 is negative 6. So 8 minus 5 is 3, 3 plus 4 is 7. 16 minus 20 is negative 4, minus 6 more is negative 10. So we have negative 7/10 as our final answer.